your best bringing your A game. Some of the explanations for things can be a little bit lengthy. Now I'm going to start with, like, when I do my explanations, I'm going to start by kind of giving you the big picture overview or whatever, and eventually we'll whittle it down to like a nice, neat procedure. But I want you to kind of understand why the procedure works. So that's why we're going to, kind of take our time maybe getting there. Get in the right period. So you guys ready to start rocking and or rolling? So we're going to start here talking about inverse trig functions in 4.1. So before we start talking about inverse trig functions, let's refresh our memory about what did we mean by an inverse function. Right? This was something we talked about at the beginning of the year in chapter 1. What do we know about inverses? It's not really the opposite. When we say opposite in mathematics, you mean like the negative of it. So like 3 and negative 3 are opposites. But that's not really what we mean by an inverse. Again, not really limiting to multiplication even, right? So if we have like our domain and range, if we have some function f that takes like something in the domain and takes it to something in the range, the inverse is just going to do the reverse. It's going to take that thing in the range and send it back to the domain. So if we have like f of 2 is equal to 5, then I know that f inverse of 5 will give me 2 back. Right? That's the idea. Everybody's okay with that? So essentially, what are we doing here? So if our function f is some set of fy's or xy's, our function f inverse is going to be a set of yx's. Yes, good. So let's kind of talk about what this is going to mean with respect to a trig function. Okay, so let's start with just say sine, right? So I'm just going to do some, use this program to generate some pictures for us quickly. So here's the graph for y equals sine x, right? Now, if I switch the x's and y's for each point that makes up this curve, I'm going to get this. If I look at that blue curve, what's the problem with this? Yeah, if we look at this blue curve, something should stand out to go, uh-oh.
Shouldn't they be like thin line? Shouldn't it be like the blue line should be flipped?
Nope. Nope, the blue line is the correct thing, but there's a problem with what that blue line looks like. Anybody think hard about this? No. You're thinking you're far away from where you need to be thinking. Think back to chapter 1 stuff. What? What do you mean it's vertical? Okay. Edu? It's not a function. Why is it not a function? It fails a vertical line test. Yeah, so that's where we're trying to get to. Yeah.
Oh my God.
So that's a problem for us, right? Because for any input, any x value I picked, I'm going to have infinitely many, in fact, outputs because this thing just keeps, going like that down forever, right? So we need to clean this up a little bit. The way we're going to do this is we're going to restrict the domain for our function sine of x. So what I want to do is I just want to include one copy of each of the y coordinates in its range. So basically I want to start here and I want it to stop there before any of the y coordinates repeat. Everybody's okay with that? So let's do that. I'll draw a picture. So there's my sine function when I've restricted its domain. It's now that little green piece. And now if I swap the x's and y's for each point on that green piece, I get that yellow, and I'm good to go, right? Now I have a function. Everybody's feel good with what we did there? Okay. So we have, bless you. So for some function, sine x, what we did is we restricted its domain to go from negative pi over 2 to positive pi over 2. In doing so, though, the range remains the same, right? That's why that's how we restricted the domain. We wanted the smallest domain so that we kept the entire range of values for sine. So my inverse then, which we denote sine inverse of x, what do you know about the relationship between the domain and range of a function and the domain and range of its inverse? Okay, let me lead you to this a little bit. The domain is about which coordinate, x or y? X. And when we make an inverse, what do we do to the x's and y's? Flip. So the domain for f is going to become the range for f inverse, right? Absolutely. And that means the range for f is going to become the domain for f inverse. Everybody's okay so far?
Yeah.
Yeah? That feels all right on how we got to here? Let's do some examples. Here, just using sine inverse before we construct the others. Okay. So here it says to find the exact value of sine inverse of 1/2. If we want an exact value, it's unit circle time again. If you have your unit circle still, please pull that out. If you need an extra copy, I'm going to pass the stack around. If you need an extra copy, take one and pass it. If you have your copy still, please just take it out. If you need a copy, take one and just keep passing. And I'm just going to kind of jog in place here while these unit circles get passed around. Kudos to you if you've managed to hold on to yours. Right? It's been a chapter or something since we've cracked this guy open again and really taken a hard look at it. And if the last of you have seen it, can you just take the stack and put it back up on the file cabinet? If he needs one, he'll grab one, right? He's got one out? Perfect. All right. So let's look at this. So we're going to be using the unit circle to do this. Let me grab my copy here. So let's look at this example. So it says we want to do the sine inverse of 1/2, right? The first thing I need to check is this problem even going to be doable, right? Does 1/2 lie in the domain for sine inverse? So basically I'm asking, is 1/2 between -1 and +1? The answer is?
Yeah.
Yes, right? It is in between those two numbers somewhere. Does that, when I say between, do I mean exactly halfway? No, not necessarily. It just means it's bigger than -1 and smaller than +1, right? Everybody's good? I guess we could have or equal to there as well. Okay, so we're good. This is a problem that we can do. Everybody agree? If it was something that was either too big or too small, we would just write undefined, right? If you try to do it in your calculator, what your calculator is going to do is give you a domain error when you try to do like sine inverse of 7 or something on your calculator. It'll just give you an error and it doesn't do anything. Cool? So far, so good? All right. Now let's look at the range here. So the range is talking about the angles between -π/2 to +π/2. So let's just kind of briefly split that up. And think about it from -π/2 to 0, and then 0 to π/2. What is π/2 in degrees? Let's talk about this in degrees, because we're usually a little bit more comfortable with that. It's 90 degrees is π/2. How do you convert that? You multiply π/2 by 180 over pi. Great. So that's the same thing as just saying -90 and then +90. So if I go to my unit circle, and I start at 0, and I'm going to +90, I'm going to there, right? Everybody agree? And if I go, if I start at 0 and I go to -90, how do I do that? I go clockwise, right? Instead of counterclockwise. So there. Everybody agree? So my answers for sine inverse are going to come from quadrants 1 and 4. Thank you. Edu,
Yes, sir.
your college search continues. Certainly. Yep. Everybody's okay with that? So whenever we're doing sine inverse, we're looking in quadrants 1 and 4. So maybe let's write that next to the range here.
Always for sine inverse.
Correct. All right. So when we look at our unit circle, we have like these points here, right? Do you remember what the x and y coordinates for these points represent? The x coordinate is cosine theta, and the y coordinate is sine theta. Right? So what I'm going to do, since I'm doing sine inverse of 1/2, I'm going to look in quadrants 1 and 4 for where the y coordinate, because we're doing sine inverse, is 1/2. That's the only place where I see in quadrants 1 and 4 where sine inverse is 1/2. Do you guys agree? So that tells me my answer then should be pi over 6. Because they were doing sine inverse of 1/2. So I get pi over 6, right? One more thing I have to do before I say I'm finished. I want to make sure that pi over 6 is in the range for sine inverse. So is pi over 6 in between negative pi over 2 and positive pi over 2?
Yeah.
Yes, because clearly it's bigger than a negative, right? And I know 1/6 is smaller than 1/2, so it's definitely in between those, right? Everybody feels okay on that? Now you could calculate the decimals if you wanted to. That's fine, right? You type in your calculator and do pi over 2 and pi over 6, and just make sure that pi over 6 is a smaller decimal than pi over 2. But like, let's just use some number sense to shortcut having to do the calculator, right? So that means this answer is correct. We're done. That's it.
Boom.
Let's do another one. Yep, it's pi over 6. So let's do another example. Let's say this time we're doing sine inverse of negative root 3 over 2. So where do I start looking? On the unit circle. Where on the unit circle?
1 and 4.
Quadrants 1 and 4. Which coordinate am I looking at?
4.
The y coordinate, because we're doing sine inverse. So we're looking for in quadrants 1 and 4, where the y coordinate is negative root 3 over 2. Yes, Luca.
How do we know what quadrants?
So it had to do with the range for our function.
Okay.
So for sine inverse, we're always looking in quadrants 1 and 4. Cool?
Yeah.
Okay. So our answer is 5 pi over 3. What do we still need to do, though?
Make sure it's between negative pi over 2 and pi over 2.
Excellent. Is it? No, right? 5/3 is bigger than 1/2, right? Okay, so this can't be our answer, right? But maybe there's another angle on the unit circle whose terminal side is in the same position as 5 pi over 3, but that angle is between negative pi over 2 and positive pi over 2. What am I talking about right now? Two angles that have the same, whose terminal sides are in the same position.
Oh, the adding 360, any multiple of 360, you go around and it's equivalent.
Yeah, that term was called coterminal. So yes, we can find coterminal angles by either adding or subtracting multiples of 360, or if we're in radians, we would add or subtract 2 pi. So here, are we in degrees or radians? Radians. So we should be adding or subtracting 2 pi. Now, should we add 2 pi or subtract 2 pi?
Subtract.
Good, subtract. Why would we subtract here? Because this is too big, right? We need this angle to get smaller, but still be in the same spot. So we're going to subtract 2 pi from this. To do 5 pi over 3 minus 2 pi, what do we need to have? Common denominator. What would that common denominator be? 3. So I'll multiply the top and bottom of 2 pi by 3. So 5 pi minus 6 pi is negative pi, and the denominator should be 3. Now let's check. Is negative pi over 3 in between negative pi over 2 and positive pi over 2?
Yes.
Yes, right? Negative pi over 2 is 0.5 pi, or negative 0.5. Negative a third pi is negative 0.3. That's definitely bigger than negative 0.5. And clearly the negative is smaller than a positive. So it's definitely in between there. Everybody feel all right there?
Yeah.
All right. Helpful tip. If your angle was in the first quadrant, won't have to worry about anything. Your answer is going to be your answer. If your angle lay in the fourth quadrant, you're going to have to subtract 2 pi. Boom. Simple, right? So far, so good? All right. How many trig functions have we talked about so far this year?
6.
6, right? How many have we done? How many inverse trig functions have we talked about? 1, right? Just sine inverse so far. Let's talk about cosine inverse and tan inverse right now, and we'll talk about the other ones a little bit later. All right. So if our function is cosine, its inverse is cosine inverse. For cosine, to make this work, we have to restrict its domain. This time we'll restrict it from 0 to pi. That's going to give us the same range. So for cosine inverse, its domain will once again be negative 1 to 1. But this time its range is going to be 0 to pi. So what 2 quadrants are we talking about from 0 to pi? Look at your unit circle.
180.
Quadrants 1 and 2. Great. You're going from 0 to 180. That's covering quadrants 1 and 2. So for tangent, we're going to do the same restricting the domain trick, but notice here, instead of using brackets, I'm using parentheses. Why am I doing that? We're still talking about an interval there. remember what the graph of tangent looks like. What does the graph of tangent have that neither sine or cosine has? Yeah, it has those vertical asymptotes, right? Right, this is what the graph of tangent looks like. Guess what those vertical asymptotes occur at? Negative pi over 2 and positive pi over 2. Remember when we have the reference point, what is the y-coordinate for tangent at negative pi over 2 or positive pi over 2? We write undefined. Everybody remember that? That means that those x's aren't in the domain of tangent. So if I'm restricting my domain, I can't include something in the domain in the restriction that wasn't in the domain of the original. That's why you're getting a parenthesis there instead of a bracket. So the inverse tangent then its domain is going to be all real numbers, but its range goes just from negative pi over 2 to positive pi over 2. And again, parentheses there instead of brackets. So far, so good? Okay. Let's do some examples now using any of these. So it's the same directions as before. I'm not going to rewrite all the directions. I'm just going to write like tan inverse or whatever. Is that cool with everybody? So I'm going to write a couple here. Oh, hey, by the way, we should probably go back and mention this again is quadrants 1 and 4, right? For the range for tan inverse. Everybody's cool? I don't know, that probably is obvious because it's the same as sine, just you have parentheses instead of brackets, but let's make mention. So let's write down a couple of these here. All right. So let's go and I'm going to drop my unit circle back in here. So cosine inverse of negative root 2 over 2. So I'm looking in what two quadrants for cosine inverse? Quadrants 1 and 2. And because we're looking for cosine, which coordinate am I looking at? X or Y? X. So I'm looking for where the x coordinate is negative root 2 over 2. Found it. So my answer there should be 3 pi over 4. Oops. No, that's okay. We should have checked to make sure this was between -1 and +1 to start. If you type that in your calculator, it's negative 0.707, so it's good. And is 3 pi over 4 in between 0 and 1 pi? It is. So we're good there. If you're doing cosine inverse, will you ever have to add or subtract 2 pi? No, you're fine. So not a big deal. Now let's do tan inverse of -1. Is -1 a real number? Okay, so it's good. We're in the domain. Let's now look for, where do I look for tangent on the unit circle? Okay, quadrant 1 and quadrant 4. But we need to remember, what is tangent in terms of the coordinates? How do I find that? So remember back from chapter 2, tangent is y over x. So if y over x is equal to -1, we know that, let's right up here. Well, x and y's are opposite signs, right? So I'm just looking at some place in quadrants 1 and 4 where the x and y coordinates are the same number but opposite signs. Everybody's okay with that? And that looks like it's here. Everybody agree? So we have 7 pi over 4. Rut-row raggy, what's the problem? It's too big. And we should know that right away because what quadrant did we pull this angle from? Quadrant 4. So the same rules for sine that we established are going to be the same for tangent. So what do we need to do to this? Subtract 2 pi. So I'm going to skip making the common denominator and showing all that work this time. Is everybody okay with me doing that? Okay. What's up, Khalil?
Why is it 7 pi over 4?
So I found the place in quadrants 1 or 4 where the x and y were the same number but opposite signs.
Okay.
Because that's the only way x over y is going to give you -1, right? Feel good? Okay. All right. And then, give me a different color here. Ooh, square root 3. Well, remember we have like y over x has to be the square root of 3, right? Is everybody okay with that? Well, I don't have like a place where I have 1 comma square root 3 on the unit circle. Yes. But what I do have is a place where I have square root 3 over 2 and 1 over 2. So like if I think about multiplying the top and bottom of this by a half, so that's really what I want, is where the x is 1/2 and then the y is square root 3 over 2. So as Joey's pointed out here, that happens at pi over 3. Yes.
So how are we supposed to know like where to keep like for sine we're keeping it to -pi over 2 and then pi over 2 cosine tangent which one's the one?
So we did that right up here, right? Tangent is the same as, same as sine, and cosine is 0 to pi. Yep. So our answer there should be pi over 3. Is that acceptable? Okay. So that's good. So I should have boxed this one before. How do you guys feel so far? Is this all right? Okay. Now, we're going to do a slightly different version of this same problem. So, what if we now ask, let's say, directions, solve for theta on the given interval. So let's say we have sine theta equals 1/2, and we want that from say pi over 2 to 3 pi over 2. So I want to talk about what this means graphically first before we go and do this on the unit circle, so that it's a little bit clearer. So if I wanted to visualize this problem, we'd have our sine function, and then we have the line, horizontal line, y equals 1/2. And every time these two intersect, that could be a possible solution, right? How many solutions do I have possibly?
5.
Remember, this keeps on going.
So infinite.
Infinitely many, right? So to answer this question effectively, I need to be looking in the right spot between pi over 2 and 3 pi over 2. So here's what we'll do. If I think about my unit circle, if I find pi over 2, that's there, and I go counterclockwise, because these are positive angles, to 3 pi over 2, I'm covering quadrants 2 and 3, right? Everybody agree? Because we're talking about sine inverse, I'm now going to look at the y coordinates and see where the y coordinate is positive 1/2. So if I do that, it's right there. So my answer should be 5 pi over 6. And I can see that falls between the interval because 5, 6 is certainly more than 1/2, and it's definitely less than 1.5. Everybody good? Does that feel okay? So very similar to what we're doing before, but this time instead of looking in just sine inverse's range for our answer, we have to look at the indicated position. Nathan.
So if it's like, if it was not you just add or subtract 360.
Then you'd have no solution. But the way the homework is set up, you're always going to have a solution. What if we have instead oh boy, wow, how did that happen? Okay. So the first thing we're going to do is figure out where on the unit circle is 4 pi to 5 pi. Everybody agree? So obviously 4 pi to 5 pi isn't on my unit circle anywhere, but let's count around, right? So we start at 0, we go to pi, pi to 2 pi, 2 pi to 3 pi, 3 pi to 4 pi. So now we're starting with what we care about, right? So we're starting 4 pi to 5 pi. So we're talking about quadrants 1 and 2. Are you okay with how I counted around to figure out what 2 quadrants we're looking at? So let's go look in quadrants 1 and 2. Which coordinate am I looking at? X. Why the x coordinate? Because it's cosine. Oh, shoot. I should have said, this isn't how that should look. I should write cosine theta equals negative root 2 over 2. Not that it matters a whole lot, but it's a different problem. Okay. My apologies. We're okay, though? All right. So if I go and look at quadrants 1 and 2, I'm looking for the x coordinate. at negative pi over, or negative root 2 over 2. So we should have 3 pi over 4. Now, is that between 4 pi and 5 pi? No, it's not, right? Is it too big or too small? Too small. So what are we going to do? Add 2 pi to it. So if I do that, I get 11 pi over 4. Again, I made a common denominator. I just didn't write out the steps to do that. So that, as a decimal, is 2.75. Still too small, right? What am I going to do? Add 2 pi again. So that's going to give me 19 pi over 4. So that's 4.75 pi. That's good. Nathan. I'd prefer you to give it to me as a fraction, but like if it helps you to make sure it's in the range, convert those fractions to decimals, right? Just give me the fraction as the final answer, but like you can work in decimals if that helps, right? Just kind of move back and forth on your calculator. I know that most of us, our number sense is much better for decimals and fractions, which is fine. So far, so good? Everybody happy still? Feeling good on what we're doing? Okay. Do I still have lots of time here? What are we doing here class-wise? How am I doing? Oh, yeah, lots of time then. Yeah, okay. Let me do one more example here. And let's say that's going to be from... So again, what am I going to do to start? I'm going to, well, before I even start trying to figure that part out, I'm going to go and figure out where this is on my unit circle. Let's figure out where we need to be looking before we even start. What am I looking for? So these are negative values, right? So which way do I need to be rotating?
Counterclockwise.
You mean regular clockwise? Yeah. So that's -1/2, -1, -1.5. So that's where we're at here, right? So we're starting there. So that's going to be to -2 and then -2.5. Does everybody feel okay? So we're looking in quadrants 1 and 4. Is that okay? That's sometimes the hardest part, is just figuring out where to look. All right. Now we know that tangent is y over x, right? Now, if I look naively on the unit circle, I don't see anything even with a 3 anywhere other than the square root of 3. I don't see any regular 3's, right? So it's a little bit puzzling how the heck we get a regular 3 in here. You guys agree? Here's the trick. What if we think about this regular 3 as the square root of 3 squared? Right? That's still the same thing as a regular 3, isn't it? Now, what can I do with this fraction if I've written it this way? I can reduce, right? You guys agree still? So that's going to be negative, and then I have 1 over square root 3. Now, I don't see still anything on my unit circle that has an y coordinate of root 3, or an x coordinate of root 3 and a y coordinate of 1. But I do see places where I have a y coordinate of 1/2 and a x coordinate of root 3 over 2, where they both have the same denominator, right? So if I think about this as just like multiplying the top and bottom by 1/2, so here's my x and here's my y. And I just need that one of them to be negative, right? So let's go look in quadrants 1 and 4 for where that's happening at. So the only place where I have, Mr. Kulik, did I do something dumb here? Oh, no, because that's x has to be this one, right? And that's 1, okay. Yeah. So again, 5 pi over 3 is tempting, but the x and y are in the wrong spots, right? So my answer here is that I'm going to use is 11 pi over 6. Everybody's good? Is that between negative 5 pi over 2 and negative 3 pi over 2? Of course not. What do we need to do? Subtract 2 pi, right? So again, making some common denominators, I get negative pi over 6. Still too small though, right? So subtract another 2 pi. That's going to be negative 13 pi over 6, which is like negative 2 1/6, right? Which is bigger than negative 2.5, but still smaller than negative 1.5, right? So this guy will be good to go for us. Uh-oh. How do you guys feel? Some of these are tricky, but for the most part, the idea is okay, right? The tan ones can be tricky in figuring out where to look for that, right? Because you have to figure out the x and y sometimes from something that's been reduced, which is not easy, but there's only a couple of cases, and once you've seen them, you're going to feel, okay, I got it. This is where I'm going to stop for today. I think this was enough. What I want you guys to work on here is going to be worksheet 1, which is doing exactly the same kind of problems we just have been practicing. So there's 12 problems on worksheet 1. So that's what I'm assigning right now. Just worksheet 1 for right now. That's all I'm assigning right now. Yeah, I'll fix that. Yep. Yeah. I wanted to, well, yesterday I did the same thing, but we had like 20 less minutes or whatever. Yeah. So I just didn't get through as much as I wanted to, and I just made a decision. But yes, thank you. I will update that right now. Oh, that minor. Okay. Yes, sir. I'm still grading them, to be honest with you. I've finished third hours and I entered theirs. Your guys, I'm like halfway through. So maybe today, hopefully tomorrow at the latest. But, like life happens sometimes. I could be bombarded by AP Calculus kids here in the next community time and study hall and stuff because they have a test coming up also. And their stuff is pretty hard. This worksheet 1 though won't be due until next Sunday, right? So what's due this Sunday? Fat lot of nothing, right? Because we already did all the chapter 3 stuff is already turned in for the last problem set. This first chapter 4 thing won't be due until next Sunday. So this Sunday, you guys have a nothing that needs to get done for you, which is super cool. I know it's the busy time of year athletics-wise for some of us, so.
Can I go to the bathroom?
Yeah.
Thanks.
Sure. Yes, sir.
It says I have like a bunch of incompletes and missings here.
Okay.
I just resynced my OneNote.